List all possible rational zeros. This one is a little bit tedious because this is the one where you have to go 1 and 35, 5 and 7, and then, well, this one's not so bad because there's only a 1 there. The only factors of 1 are 1. But you have to take all of the numbers on the right divided by all of the numbers on the left. Those are all the possible rational zeros. So I would say 1 over 1 and 5 over 1 and 7 over 1 and 35 over 1. Now, normally there's more than just one blue number, but if there were more than one blue number, you'd have to take all the red numbers divided by all the blue numbers, and then clean it up a little bit. You're going to reduce your fractions and say plus or minus. Plus or minus 1, plus or minus 5, plus or minus 7, plus or minus 35. And what that says is not that those are the zeros, those are the ones that would be possible if we're doing synthetic division and if it's going to work. If synthetic division works, then it's got to come from this list. So part B says find all rational zeros. Part B says, okay, now let's narrow it down. Let's find the one that works, the ones that work. If you look at this expression, you would expect 3 of them to work, or at most 3 of them to work. Definitely not all of them. So you just have to just try some numbers. Add down and multiply, add down and multiply, add down and multiply, and hey, all right, one of them works. The first one we tried works. That hardly ever happens. Okay, so I know that 1 is one of my rational zeros, so that's great. Okay, I could keep going and try other numbers unless you notice that we've broken down the equation into a smaller polynomial, and I know how to factor that. If you look at, x squared minus 12x plus 35, you probably know how to factor that. 2 numbers that multiply to 35 and add up to negative 12 would be negative 7 and negative 5. That gives me a 0 of 7 and a 0 of 5 to go along with my 0 of 1. Those are my answers. Okay, so notice the difference between part A and part B. Part A says list everything that's possible. Part B says find the ones that work. Part C says factor. Well, that's easy after you know the solutions. 7 must have come from x minus 7, 5 must have come from x minus 5, and 1 must have come from x minus 1. Those are the factors. Okay, now here's something that I don't think you're very good at. It's not very hard, but it's just, I don't think we've seen enough examples. So make sure you're sharp, make sure you're paying attention to this. Find the possible number of positive and negative real zeros of each function. So let's talk about positives first. This is Descartes' rule of signs. All right, so in order to look at the positive number of real zeros, see how this coefficient is positive, and this coefficient is negative, and this coefficient is negative, and this coefficient is positive. Okay, you're looking at the signs. It's called Descartes' rule of signs. He's looking specifically, or we're looking specifically at where it changes. So right here, there's a change from positive to negative. And then right here, there's a change back from negative to positive. So you see how there are 2 changes? Okay. Now, what you have to do is kind of tricky, and people don't understand, is you have to subtract 2 until you get to 0. So for the possible number of positive zeros, our answer is going to be 2 or 0. And so whatever number you came up with, let's say you came up with 7, you'd subtract 2 until you got down to 0. 7 or 5 or 3 or 1. If you got 4, it'd be 4 or 2 or 0. Whatever number you get, you're going to subtract 2 until you get down to 0. That's just what you do. Well, you won't get, if it's an odd number, you won't get to 0, but once you would get to 0, you'd stop. Okay? So I don't want any negatives. So go down as far as you can without getting any negatives. All right. So good question. Now we have to talk about the possible number of negative real zeros. So this one's a little bit harder. I'm going to move this 2 real quick because I need a little bit more space. It's a little bit harder because what you're going to have to do is you're going to have to take the function and change your x to a negative x. So if I'm talking about the negatives, I'm going to take every x and change it to a negative x. So that's going to be negative x to the third minus 6 times negative x squared minus 9 times negative x plus 14. Now, this term right here is a negative to the third power. Negative to the third power gives me 3 negatives, and I know 3 negatives makes a negative. This is negative right here. This term right here, negative 6 times negative x to the second power, well, negative squared is positive, but then there's that negative 6. So I see 3 negatives there. There's a negative and then a negative squared. There's 3 negatives, so that's still negative. This term right here, negative times negative is positive, and then, of course, this one is positive. So Descartes' rule of signs, you're looking at the sign change, and there's only one sign change right there. Okay? There's one sign change. So the possible number of negatives is just 1. Okay? That's all there is to it. I know people really struggle with that, so let's do another example. For the possible number of positives, it's easy because all you have to do is look at the function. First term is negative, second term is positive, positive, negative, positive. So that's a sign change here, and here's another one, and here's another one. So the possible number of positive real zeros is 3 or 1. Okay, we see 3 of them. 1, 2, 3. So it's going to be that number minus 2 until you get down to 0. Okay, 3 or 1. The negatives is harder because you have to do this extra step of changing x to negative x. If you're too lazy to do that, then you're going to miss an easy problem, I think. Okay? So once you do that, you have to examine each term and figure out if it's negative or positive. I look at this first term, and I see a negative times negative to the fourth. I see that as being 5 negatives. I see 5 negatives, so I know that first term would be negative. I see this next term, and it's a negative cubed, so I see 3 negatives, which is negative. I see that next term, and it's a negative squared. That's 2 negatives, which is positive. The next one, negative times negative, is positive. And then, of course, this is positive. So I only see 1 sign change. That means the possible number of negative real zeros is just 1. Okay, once you understand that, it's simple, but a lot of students struggle. So make sure you look at it. All right. Is this thing a 0? Well, we've done that a lot of times. You're just going to do synthetic division, right? Well, that's one way anyway. Is this a 0? Add down and multiply, add down and multiply, add down and multiply, add down. And so check it out. Looks like, yes, it is a 0. Yes, negative 3 is a 0. Of course, you can tell that because we got that number 0 right there.